Hello students, now we are going to start last unit of our crash course program, Unit 19, Electronic Devices. To start our 45 problem assignment, first we will discuss some key points. What are energy bands? We divide material in three parts. Insulators, semiconductors, and conductors. What is difference between these three? All have one valency band and after that one conduction band. Conduction band and valency bands. The gap between conduction band and valency band is known as forbidden energy gap. Forbidden energy gap. In this it is more than 10 electron volt. In semiconductor it is of order 1 electron volt. And in this both bands overlaps. If this gap cannot be filled by external energy, material is known as insulator. If you can fill this gap by supplying a little amount of energy, these are known as semiconductors. If already electrons are present in conduction band, then it is known as conductors. So, most common example of semiconductors are silicon and germanium. For germanium at room temperature, this forbidden energy gap is 1.1 electron volt, and for silicon it is 0.7 electron volt. We will discuss about semiconductors. Both belongs to fourth group. They need 4 electrons to complete their outermost shell. What is happening? All electrons are bounded by covalent bonds. No electron is free to conduct electricity or electrical energy. But at room temperature, material got energy from external source, means from room, and some covalent bonds are breaked. So electrons are free to conduct electricity. So it will become a conductor. Even at room temperature, semiconductor will become conductor. If you supply more temperature, more heat energy, more covalent bonds will break and its conductivity will increase. So you can see its resistivity has negative temperature coefficient. We can increase its conductivity by one more way. You can add some impurities. If you are not adding impurities, in pure form, it is known as intrinsic semiconductor. If you are adding impurities to increase its conductivity, it is known as extrinsic semiconductor. In impurities, you can add third group impurities or fifth group impurities. If you are adding third group impurities, what will happen? Third group elements has 3 electrons in their outermost shell, but this semiconductor needs 4 electrons. It means deficiency of 1 electron, and deficiency of electron is positive charge, means hole. So it will increase positive charge carrier, means hole. So this type of semiconductor is known as p-type semiconductor. But if you are putting impurities from fifth group, they have 5 electrons in their outermost shell, but semiconductor needs 4 electrons, so 1 electron is in excess. So each atom of impurity will donate 1 electron to conduct the electricity. So number of electrons will increase, and this type of semiconductor is known as n-type semiconductor. And in pure semiconductors, number of holes and number of electrons is same. Both are responsible for conductivity of charge or electricity. If you are doing one thing, you are adding in half semiconductor third group impurities, and in half you are adding fifth group impurities. What will happen? Their holes are in excess, so they will move towards this portion. Here electrons are in excess, so they will move in this direction. Between the two, when they meet, they will neutralize each other. But if for some collision was not possible, they will cross. So they will cross and they will come to this end. The electrons which not met with holes, they will cross. And now what they will do? They will repel the electrons which are coming behind them, and holes which cross this portion, they are here, and they will repel the holes which are coming behind them. So it means one barrier is formed between the two type of impurities. It is known as depletion layer, and it is just like a battery whose negative terminal is here and positive is this, and this battery is known as potential barrier. It is potential barrier. For silicon, this potential barrier is 0.7 volt, and for germanium it is 0.3 volt. If you are adding one external battery so that positive terminal is connected with P and negative terminal will connected with N. What you are doing? You are adding battery opposite to that, means you are making this potential barrier weak. So this type of connection of external battery is known as forward biasing. When you are making potential barrier weak, means you are decreasing the length of depletion layer. But if you are connecting like this, you are connecting negative terminal to P and positive terminal to N, it means you are strengthen this potential barrier. Same poles, like poles, same type, plus plus on this side, minus minus on this side. You are making strong to potential barrier. So this type of biasing is known as reverse biasing. What reverse biasing will do? It will strengthen the potential barrier. So it will block the motion of charges which are crossing the barrier due to their high kinetic energy. But if you are continuously increasing the reverse voltage, reverse biasing, at one time you will see the current is totally blocked. But further, if you are increasing the reverse voltage, after some time you will see sudden increase in the current, means there is a breakdown of your barrier. There are two types of breakdown. One is known as Zener breakdown and another one, different reasons for that, another one is avalanche breakdown. Since semiconductors are not obeying Ohm's law, so they will not follow Ohm's law, they are non-ohmic resistances, but ratio of delta V and delta I, it is current, but it is known as dynamic current. Dynamic current. What this type of junction, PN junction or NP junction, what it is doing? The symbol of this junction, which we are saying PN junction, is this. This is representing P and it is representing N. It is PN junction. Means in this part P type impurities are there and in this part N type of impurities are there. And what this PN junctions function? It will work only if it is forward biased. In reverse bias, it will block the current. So since only one way traffic is on, so we are using this device to convert alternating current into direct current, means for rectification of alternating current. With one PN junction, you can convert half cycle of AC into DC, but with the help of two, you can convert full cycle of AC into DC. So use of this is to rectification. And Zener breakdown, we are using that for stabilizing the current. Since in AC fluctuation is there, voltage is going high, voltage is going down. To making it stable, we are using Zener diode. Getting my point? So now 2-3 types of diode we are using. We are using this also for in photoelectricity. Photodiodes are there. What are photodiodes? In this we are getting light energy. So symbol of photodiode is this. What is in photodiode? In photodiode, we are using reversed biased. Due to high resistance, your electrical energy is converting into light energy. One, its use is in photodiode or special type. In that we are using reverse biasing. Second one, solar cell or photo cells. What in that we are converting light energy into electrical energy. So in photo cell or solar cell, what is symbol? We are using this symbol. We are converting light into electric energy. We are getting light from electrical energy in this. In that symbol is this. In that what we are using? In solar cell, no biasing is there. No biasing is there. So it was the function of diode. Next important thing, in which from which sector you are every year you are getting problem, that is transistor. Most important part of this chapter is this transistor. We are using transistor for amplification as a switch, and these two uses are in your syllabus, mainly amplification. What is transistor? Transistor we are using two junctions, two diode junctions are there, NPN or PNP. But remember, in a transistor, all are not equal width. All are not equal width. Ammeters are, and name of these three portions is, this is ammeter. This is known as base, and it is collector. All we have discussed in our theory slides, so only I am giving you tips. Ammeters are highly doped. Doping means putting impurities in that part. If it is NPN, we are putting in this part fifth group impurities. It is highly doped, and collectors are moderately doped, and base is lightly doped. In every experiment, we are always putting ammeter base junction in forward biasing. In forward biasing means we are connecting N with N and P with P. And collector base junction, it is always in reversed biasing, means N with P. This junction is always in reversed biasing. And this junction is always in forward biasing. So, what important terms are related to this? We are discussing common base. current amplification. Common base means base is connected to both ammeter and collector. It is common. In this, current amplification is denoted by alpha and it is known as delta IC upon delta IE. VCB is constant, alpha alternating current we are using. Next one is common. I will give you one short trick, no need to learn each and everything. Common ammeter current amplification. It is denoted by beta. It is known as delta IC upon delta IB. VCE is constant. And relation between alpha and beta is this: alpha is equals to beta upon 1 plus beta. Alpha is equals to beta upon 1 plus beta. And three types of gain are there. First is current gain, beta, delta IC upon delta IB. Second is voltage gain. It is denoted by AV, means output voltage upon input voltage. Remember, always output is collector. What is input? It depends upon the circuit which we are using. That is known as input. So, output voltage, I will give you short trick, so it was easy to learn you. It is equal to minus beta, output resistance upon input resistance. Minus means output voltage and input voltage are in opposite phase. Output voltage and input voltage are in opposite phase. So now I am giving you short trick. No need to remember all results. It is trick which is very useful for you, because detailed discussion we have in our theory slides. Trick. How to remember? Two types of problem you will get: common base or common ammeter. Make this diagram. Which is common to both portion? Common base. So write here base. It is output. It is input. Output is always collector. Output is always collector. Common ammeter means ammeter is common. So what is remaining? In this case, remaining is collector and base, both are used. So remaining is ammeter. Means ammeter is playing the role of input. Input voltage means voltage of ammeter. Input resistance means resistance of ammeter. Output is always collector. In this, C and E are used. What is remaining? Base. So in this, base is input. Output is always collector. So if I am talking about input resistance in common ammeter, it should be resistance of base. So remember this. So now for this current gain, current common base first we are discussing. They are saying current gain. Means what is your current gain? Always ratio upon what you are getting in output and what you supply in input. So current gain means what you are getting in output. What you supplied in input. Input was IE. What is voltage gain? Voltage gain means what you get in output, means voltage of this junction is collector base, output voltage. What you supplied in input, it is EB. So in this way you can calculate each and everything. If you want to gain power gain, you know that what is power? Power is V into I, means voltage gain into current gain. So beta into AV will represent power. So it was all about the theory. We revised. Now we will discuss problem based on these.